Yeah. Hi, Arshil. We can get started now.
Yeah. Uh, Good morning, everyone. This is Harshil Shah.
Hi, everyone. This is Pankaj Shukla.
Hi, this is Ramabhatran Sampath. We are in from Group 11.
So we'll be presenting our project on aiding diagnosis with the help of artificial intelligence to predict breast cancer. Uh, Pankaj, if you can change the slide.
Yes.
Yeah. So according to WHO, the World Health Organization, uh, breast cancer remains one of the most common cancers worldwide, and early detection is a key for improving the patient's survival rate. However, diagnosis process can be anxious and uncertain for the patient and the family. Even for the healthcare providers, it is very important to deliver a quick and accurate diagnosis. So we were set to address the important question that how technology could be useful and how we can use technology to make the process faster, even more accurate and less stressful for everyone involved in the process. Uh, Next slide, please. So our objective majorly was to develop a reliable digital tool that can classify breast cancer as either malignant, meaning cancerous, or benign, meaning non-cancerous tumor. The goal was into threefold. First, to support the doctors for offering a powerful data-driven second opinion to enhance their clinical judgment. Second, to improve the patient experience by reducing the waiting time for results. And third, to make the diagnostic process more efficient, preserving the valuable time and resources in the healthcare system. So, with this objective, we started working on this project, and now I'd like to hand over to Pankaj for further explaining.
Thanks, Arshil. So I'll get started with the data and model aspect. So, in order to tackle this kind of problem statement, we needed a high quality standardized data set. So we looked at multiple areas and we found that in UCI machine learning repository, there was a breast cancer Wisconsin data set, which is a clinical data set which is verified, and we basically went ahead with this data set. It had characteristics like radius, texture, and symmetry of the cells, and the outcome as well, which is whether this kind of characteristic attributes to a benign or malignant tumor case. So with this information, we went ahead and we decided to build a predictive model. Now, when we talked about predictive model, there were multiple approaches. So, given the kind of the kind of progress we have made in artificial intelligence and machine learning field, so we chose to go ahead with machine learning techniques directly, and we built a predictive model on this particular data set. Now, this particular model can be treated as an assistant, which is which is highly intelligent and can help the doctor to find subtle patterns in the image that will be observed with given attributes of the cell, and basis that the it can help doctors to understand whether this is likely to be a benign or malignant case. Now, I'll quickly jump on to the approach that we took. So, we basically did a quick scan of the data set with respective models. So there was a library called as Lazy Classifier, which is an open source library, which had multiple models. Again, these all are ML models, and we basically checked which model gives us a high accuracy. So what we found is there were a bunch of models, roughly four to five, which were giving an accuracy of 95 to 97%. So we went ahead with that list. So initially, to start with, we had four models. Then we focused on each one of those models. Okay, and we used a open source library known as scikit-learn there. There again we tried with multiple sets of data set, the same data set, you know, separated into training and test. And with multiple approaches, we were able to finalize one model which was giving us a high accuracy and sensitivity. I'll cover accuracy and sensitivity definition in the next slide. Once we finalize this model, what we did is we wanted to be sure that this kind of model can be generalized and can fit well with the new data set that will come. So we did a grid search cross validation approach, where we were able to finalize one model which gave us the best accuracy and the best sensitivity. Now, when we talk about accuracy, it's mainly, if I quote in simple terms, it's basically the number of times the machine is or the model is predicting a tumor to be benign or malignant, how many times the model is correct. If it is very high, then means the model is very accurate. Then the second metric that we use to evaluate is sensitivity. So it helped us to understand from all the actual from all the actual cases of benign or let's say malignant tumor, uh, is the model is able to classify them accurately or not. So that was the second metric, which again, if it is in a higher number or a higher value, it means that the model is predicting it correctly. So with all this, this is a quick summary that we plotted, which will help all of us to understand, what all stages were there in our approach. So first one was broad scan, where we used the lazy classifier. Here the models that we picked had the maximum accuracy of 0.97, and it ranged from zero point 0.9 to 0.97. So we picked some of those models. Then with the refined machine learning model, we got an accuracy of 0.96 and a sensitivity also of 0.96. After fine tuning, we finalized one model or one technique which gave us the highest accuracy and highest precision and highest sensitivity, which was 0.9%, and XGBoost was the model that helped us achieve this one. So we basically have now finalized this model, and the next steps whatever we'll take, we'll basically use this model going forward. Now, with respect to the applications of this entire observation that we did, Ram will cover the application and the impact part.
Yep.
Ram, over to you.
Thanks, Pankaj, and thanks, Ashil. As Ashil and Pankaj rightly said, the correct identification, basically, the patient is so anxious and he needs to find out whether there is any false positive because the patient's life is around that. So, this is very critical for the patient. So, the model, what we have done is going to help out basically the patients to diagnose it properly and reduce the number of false positive so that the patients can trust on the results onto it. And from the person's perspective, this is going to be helpful further because it's a life taking decision. And from the doctor's perspective, that's going to be a very good business aspect onto it. Example for their reduction in the error rates, and basically that will help them to get more patients confidential level, and it indirectly going to help out the business part of it, and it is going to be a competitive edge compared to other hospitals if they start using these models. Moving to the next slide. So, what are the next steps? So, since we have done the models and what we need to do on the next steps, if you look out, these models can be improved by using a kind of a user interface. We can create a simple and intuitive dashboard for basically the clinicians who is going to really test the patient's tumor size, or whether to find out whether the tumor is present or really needs to be treated as a cancerous one or not. So those clinicians can use these intuitive dashboards to use our model in the background to find out really the identify the cause of the tumor, and also the whether it is a false positive or whether it needs go for a treatment or kind of stuff. And even some of the clinical validation also can be done with the partners. Basically, we can get for with more new data sets, which will improve the model accuracy percentage in a better way by adding few more new patients results and other things. So the clinical validation and basically this can be expanded to multiple other AI applications also, not only for the cancerous things and other things, even for any other related to scanners and images related for disease identifications can be used on this model. So this model is going to be a very good one with the XG boost with 0.97 accuracy and 0.97 sensitivity. We can show that it is going to eat out the market well. Thank you.
Great. Thanks, everyone.
Thank you all.
Thank you.